So today I'm going to continue solving the 1D motion word problem we were solving in the past two videos. This word problem models a motorcycle's motion driving east, and in the first part we found its position and velocity at time equals 2 seconds. Now the problem wants us to find the motorcycle's position when his velocity is 25 meters per second. So we can start by redrawing the diagram and putting in the information we already solved for in part A. So we were able to find the velocity at 2 seconds to be 23 meters per second and his position to be 43 meters. And we got to identify that we need the x position when the velocity is 25 meters per second. And I just want to note that the motorcyclist velocity is increasing because we can see that the initial velocity is 15 meters per second, and then at 2 seconds it's 23 meters per second. And it wants us to find the velocity at 25 meters per second, so we'll know that the time is going to be greater than 2 seconds. So our next step is to write down the equations we have. So we have our velocity equation and our position equation here, and we should identify that we have two unknowns. We have the time and the x position. So first we can use the velocity equation to find the time, and then use the time and the other givens to find the x position. So if we start with the velocity equation and plug in the values we have, we get this expression here, and then we can isolate for t by bringing 15 to the other side, and then we can multiply both sides by 1 over 4 meters per second squared to isolate for t. And if we do that, we're just left with this expression here. So on the left hand side we can divide 10 divided by 4 and we get 2.5, and then we can be able to make sure to divide the units. And dividing by fractions is the same as inversing and multiplying, so meters per second divided by meters per second squared is the same as meter per second times second squared divided by meters. So if we do that, we can cancel out the meters and one of the seconds, and we're left with seconds. So we got our final answer here for the time equal to 2.5 seconds. So that's going to be the time when the velocity is 25 meters per second. So now we can plug this into the position equation to find the position when the velocity is 25 meters per second and get our final answer. So if we plug in our values here, and then we can do this multiplication here. So if we multiply the amplitudes, we get that. And if we multiply the units, we just cancel out to meters. And we're left with this expression here. We can square this bracket here, and we're left with 6.25 seconds squared. Remember, you square the units and also the amplitude. So if we plug that into the expression we already have, then we can multiply these amplitudes here, and we get 12.5, and then we gotta make sure we multiply the units as well, and the second squared cancel out, leaving us with meters. And then if we plug that into the expression and just add them all up, we get the position equal to 55 meters, and so that's going to be the position when the velocity is 25 meters per second. And just a final note, for these kinds of problems, the main equations you'll need are always just the position equation and the velocity equation. So every 1D problem can be solved with these two equations. However, despite this, I just want to note that if we actually remembered the time-independent motion equation, we could have solved this question a lot simpler for part B. We could have just plugged in the values we got into this one simple equation and got the answer. This is not necessary, but if you remember this, you could have solved that question faster.